so good to see you again. It is time for our homework demo video for homework 3. If I could get my little sparkly up here, there we go. You should have already read and taken notes on section 2, part 3 about the distributive property, and then we'll talk about that now. So here we go. The distributive property, it is our third property. We dealt with the commutative property and the associative property. Now the distributive property, and here is what it says. It's really very simple. It says that if you have a number sitting outside of parentheses and you have something inside of the parentheses that has a subtraction sign or an addition sign, then you need to multiply this thing outside times both things inside. So you need to say 3 times 4x, that's what they did right here, 3 times 4x. Get an answer to that. 3 times 4 is 12, so it's 12x. Then we need to multiply 3 times the 7 over here. That's where they've done that right here, and the answer is 21. So what the distributive property tells us is that if we have something on the outside that needs to be multiplied, then it needs to be multiplied by both things inside. This is our final simplified answer to this problem. I hope you know that we cannot combine these two terms, and I hope you know why. This first term has an x in it. This last term is just a number. It's the constant term. And these two terms are not alike. They don't match, so we can't combine them. We must leave them separate. If there were an x right here, then we would be able to combine the two. But they don't match, they don't combine. So let's come up with some examples of the distributive property. So something like I could have even a 5 on the outside, and then on the inside I might have x plus 3. And I could have something like 20 on the outside, and on the inside I could have 2x minus 7. In both cases, I would need to multiply twice. 5 times x, all we can really say is 5x. Just set it next to each other to say we're going to multiply. 5 times 3 is 15. How do I know what sign to put in between them? The one I start with. So I had a plus sign, I still have a plus sign. There's my simplified version, and don't make the mistake of adding those two terms together. They are not like terms, they don't add together. 20 times 2x, well, 20 times 2 is 40, and I need to lay the x next to it. 20 times 7, I think 2 times 7 is 14, so 20 times 7 must be 140. Again, we do not have like terms. We're going to stop right there, and that's the distributive property. Let's just look real quick at a couple of more properties. I know these are kind of weirdos because they're things you already know are true, yet we're making you name and talk about why they're true. And I know that's a little bit difficult, but very doable. You can do this. So, 2 more really quick properties, the identity property and the inverse property. They're both our I properties, so I try to help you keep them separate by showing you little pictures. Identical, I think of these little identical twins, and I think of how would you do something to a number, either multiply or add, and get the same thing you started with. How do you get the identical thing? Well, the answer is, if you're multiplying and I want 6 to not change, then I would say if 6 times 1 is the same as 6. That is a demonstration or an example of the identity property of multiplication. I multiply anything by 1, I'm going to get what I start with. The identity property of addition says that if I add 0 to anything, I'm going to get the same thing I started with. So another way that you see this identity property a lot is it says, what's the difference between, or is, we know that x is the same thing as 1x. Well, that's a good demonstration of the identity property because it's saying 1 times x is the same as just x. And you'll see that one in the homework, I'm sure. The inverse property, I kind of think of trying to go upside down or trying to think of how you would make something go away. So what I mean by go away, when we're adding, like right here, if I have 7, how do I make 7 go away? Well, I subtract 7, right? And I get 0. So the inverse property says that if I add the opposite, and I know that sounds weird because you don't think of subtraction as adding the opposite. The identity property says if I add the opposite, so let's go 7 plus -7, which we'll learn soon is very same as what I wrote down at the bottom, is 0. Well, the inverse property just says if you add the inverse, you're going to get 0. It goes away. How do you make something go away with multiplication? You multiply by the reciprocal. And we'll get more into this later too. Right now we just want you to be able to identify them. So don't get too wigged out about the details. Here's how you make something go away with multiplication. If you have 5 and you want it to go away, you multiply by 1 over 5. And when it goes away, instead of getting 0, you get 1. Because 5 over 1 times 1 over 5 is 1. You could do that with anything. And that, by that, I mean you can multiply by the reciprocal, and we'll get 1. So let's just look now at some examples of these. Actually, I put them all on one page for you. I'm going to flip by that really quick. It's just really here for you as reference. And here are some examples of each of the properties you've learned. I'm not going to do too much with commutative and associative. I think, yeah, here's a good example of identity. How did I get the identical thing? This is an example of the identity property. I multiplied by 1, and I got what I started with. Here's a good example of the inverse property. I added the opposite. 4 plus -4 gets me to 0. That's the additive inverse property. Now here, and this looks kind of weird, the multiplicative inverse property. They put they put 0.25, that's 1/4, right? So 1/4 times 4 over 1 is 1. So just changed it to decimal, it still represents the inverse property. If I multiply 4 times 4 over 1, I get 1. And that is a demonstration or an example of multiplicative inverse property. Distributive property, I just want to look at real quick since we just learned it. I want you to take note that sometimes it goes backwards. So today we saw it this way. Remember, we had the 2 on the outside, we multiplied 3, and we got this. Sometimes you'll see this, and on the other side, the 2 will be on the outside. Either direction, it's still the identity property. It's still the distributive property. Sorry. Okay, now let's look at some examples. You're going to see exactly this kind of thing in your homework, so watch closely with me. Here's what we're trying to do. It starts out with a problem here, and it wants you to look on the other side of the equals to see what's different. We're looking for what's different. What I look at first is the order of the numbers. So over here I see 4, then 3, then the x cubed thing, and the 2. Now look on the other side of the equals. I see the 4 term, the 3, the 1x term, and the 2. They're in the same order. That tells me right away that I didn't commute. But look what I did do. On this side, I have parentheses here. On the other side, I have these brackets in parentheses. So suddenly, I see my change. And what changed? Only the grouping symbols changed. And grouping symbols have to do with how you're associated, who you associate with, right? Who are your friends? And so that one is the associative property, and it might say associative of addition because there's no multiplication involved in it. So on the next step, we're now looking for what happened different between this guy and the one below him. So that's a little bit easier to look at. Notice again, I have a 4x cubed. Uh-oh, my order just changed. I don't see the 3 next. I see the 1 and then the 3. As soon as I see that order change, I see those numbers flip, I'm done. I know what my answer is. They commuted. The numbers moved. So this must be the commutative property. And I actually think I'm messing up here. I can go to a new slide. Yep, there's my associative property. Wrote it in nicely. There's the commutative property. Now let's see what's on the next guy. Let's see what changed between here and here, and we'll write the name of that step right here. So what changed? The order looks like it's staying the same, right? Now those numbers are all still there. The 4, the 1, the 3, and then the 2 in the same order. But again, it looks like my grouping symbols changed, didn't they? The parentheses are in different places. I'm pretty sure this one's going to be the associative property again. Who you associate with. And yeah, there we go, right there. Let's try it again. What changed between here and here? Well, let's see. Ooh, the very beginning looks different. I see this x cubed in the out front, but in the problem above it, I see an x cubed here and here. But guess what? That's the distributive property backwards. But it's still the distributive property. We multiply this through, and we get 4x cubed. Multiply here, we get negative 1x cubed. So that's showing you the distributive property. And let's put the name, yep, right there. This next step is easy, so I'm not going to talk too much about it. They call it the addition. They just call it addition. We are going to add 3 and 2 and change it to 5. All we did in that step, and we also, sorry, I put it back, we also added together 4 and negative 1 to get 3. So we just did the addition. We can combine those numbers, and we're just going to call that addition. That you're not going to have to answer a question that asks you that. Very last one is, this one says 3x, sorry, this one says x cubed, and then it has the 3. This one turned it around, and the 3 is first. So it changed the order. It's beautiful. And that one is the unity property. Okay, just really quick, a few more things. I know this video is longer than it should be. We just have too much to cover here. We have looked at these definitions before. We've even looked at this slide that reminds us that we can multiply these numbers up front, 4, 2, and 5. That gives us 40. And we just set the letters next to it, or the variables. You can only add when there are like terms. So we can only put together x's with x's to get 6x, numbers with numbers to get negative. So terms. This has 4 terms. I combined the terms until I got 2. Constant, the number at the end is the constant. These are really important definitions. Coefficient, the numbers in front of the variables are our coefficients. And like terms, the ones that match. 4x is a like term with 2x, and 8 and 11 are like terms because they're both numbers. Now let's just see if we can work some of these problems. There are 5 ways to write 4 times x in algebra. I just wanted to throw them in there to remind you of all these different ways to write. You won't see me using the x very often. In these problems, I have used x as multiplying. So this is just telling me I have 3 things, 3 terms to multiply. 2 times 3 is 6. 6 times 4 is 24. And I'm going to let the letters just chill out on the side there. 24 ABC. The next problem is very similar. I multiply the coefficients. These numbers up front. 5 times 2 is 10. Times 3 is 30. And again, I'm just going to write the letters next to it. Same thing here. Multiply coefficients. I get 10st. Now notice the difference in number 4. All of a sudden I have subtraction, and this is the distributive property. You have to make sure and multiply 3 times 2x, you get 6x, and then 3 times that 1, get 3, the minus sign is same. Can't combine these two things, they are not like terms. And here is the distributive property, only this time it happens 3 times. I got to multiply by 5a, which gives me 10a. I have to multiply by negative b, which gives me minus 2b. And then I have to multiply my 2 on the outside times that 7 to get plus 14. So just to show you, the distributive property works with more than 2 things in the parentheses. You can have as many things in those parentheses as you want. And you just keep multiplying until you get it all. A few more examples I'm hoping that will help you out. So simplify, it says, I need to look at where are my like terms. Well, I see an A term and an A term. Then I see a B term and a B term and a B term. So let's get our A's together. 3a minus 2a is going to give me 1a. And by the way, I normally would just write that as a. A and 1a are the same thing. My b's, I've got 5 and 4 more, that's 9. and 7 more is 16. So plus 16c. That's my final answer. I cannot combine those because they are not like terms. I could put a 1 in front of my a. Don't usually do that. Here's the distributive property, and there's a fraction, so it's going to scare you, right? 6 times 2, 12s. 6 times a half. Don't let that scare you. What's half of 6? 3. And that's all there is to it. Multiplying quickly through here. 10 times 2m. And 5 times 2m, sorry. 5 times 6n. Just multiply the coefficients. 30n. Last but not least, 5 times that 3 is 15. There's a minus sign in front of it, so I'll keep it. There's an n next to it. I'll keep it. How many terms are here? I hope you know there are 1, 2, 3 terms, that negative 7 is the constant term, and that none of these terms are like terms. They don't match. Last one on here, I know this looks really hard, but it's easy if you think about what you have. You're adding fractions, but look guys, these two pieces have the very same denominator, and when I add together 2/5 and 3/5, I get 1 whole. So I could just think about it as, oh, this isn't really here, but there's 1 added to the end. Then I notice, oh, there's 7/9 and 2/9. Well, that's 9/9. That's another 1, isn't it? These aren't really fractions. It's really whole. And I'm just adding them all up. 2 plus 9 is 11, 12, 13, 14, 15. Not near as bad as it looks if you just think about, oh, those fractions are going to add together and make nice whole numbers. Almost done, guys. This is what we learned today. How's your long video? I know that you are able to go back now and work on homework 3. I know you know where to come for questions. I just hope you will come for questions when you have them. Have an awesome day, and I will see you very soon when it's time for the next video. Bye now.